For this example, we'll list all of the possible rational zeros of a polynomial function, and then we're given the graph to help us find the rest of the zeros. So, here's our function. If we're listing all of the possible rational zeros, in the numerator we want all of the factors of the constant function. So we want plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. These are all of the factors of 15. In the denominator, we want all of the factors of our leading coefficient 2. So we just have plus or minus 1, plus or minus 2. So let's list what these are. We're going to have plus or minus 1 divided by 1, plus or minus 3 divided by 1, plus or minus 5 divided by 1, and plus or minus 15 divided by 1. Then we'll take each of these factors in the numerator and also divide them by 2. So we'll have plus or minus 1 half, plus or minus 3 over 2, plus or minus 5 over 2, and plus or minus 15 over 2. So here is the complete list of our possible rational zeros. Now let's move on to part B. Let's use the graph of our function and synthetic division to find all the zeros. Well, based on the graph, we can see that the graph crosses the x-axis in 4 different places. But only one of those places, right here at -1, does it cross right on an integer value. So we know that -1 is one of the solutions to our equation. Or in other words, it's a root of our function. So we're going to use -1 with synthetic division, and we're going to use our coefficients right here given. So we'll have 2, -1, -13, 5, and 15. We'll bring down the 2. -1 times 2 is -2. We add -1 plus -2 and get -3. -1 times -3 is +3. -13 plus 3 is -10. -1 times -10 is +10. 5 plus 10 is 15. -1 times 15 is -15, and we have a remainder of 0. We knew the remainder would be 0 because we could see that -1 was a root based on the graph of the equation. Well, how do we find the other roots? Here's how we're going to do it. Let's start with our original function. We have 2x to the 4th minus x cubed minus 13x squared plus 5x plus 15. And we can say that this is equal to combination of factors. We have the factor x minus our first root of -1, which is really the same as x plus 1, times the remaining factor, starting with this coefficient 2, it's going to be x to 1 degree lower than our leading coefficient. So our leading coefficient was x to the 4th. This will be x cubed. Then we have minus 3x squared minus 10x plus 15. So in order to find the other zeros, we need to simply factor the remaining factor and set it equal to 0. So we have 2x cubed minus 3x squared minus 10x plus 15 equals 0. Let's factor by grouping since we have 4 terms. If we factor out x squared, we have 2x minus 3 left from the first 2 terms. If we factor out minus 5, we'll have 2x minus 3 from the last 2 terms. And if we factor out the 2x minus 3, we'll have left x squared minus 5 equals 0. Let's set each of these factors equal to 0. If we set 2x minus 3 equal to 0, we'll get a solution x is equal to positive 3 over 2. If we set x squared minus 5 equal to 0, we'll get the solution x squared is equal to 5. By the square root property, we take the square root of both sides and we get x is equal to the positive or negative square root of 5. So now we're ready to state our final answer. We want to find all the zeros. Our first zero we found was negative 1, so we'll list them right here. Negative 1. Our next zero we found was 3/2. And then we also had our last two zeros, plus or minus the square root of 5.